Welcome to Precalculus Lesson 3.7, Inverse Trigonometric Functions. Let us recall the previous lessons on graphing trigonometric functions. There are 6 of them. We have sine, cosine, tangent, cosecant, secant, and cotangent. For this review, let's have y equals cosine x. You already know how to graph that one. And the domain is the set of all real numbers. The range is the set of all real numbers between -1 and 1 inclusive. And the period is 2 pi. We know that the graph is a function. However, the graph is not a one-to-one function since it failed in the vertical line test. That would lead us to our lesson for today, which is the inverse trigonometric function. Inverse of a function denoted by f exists if the function is one-to-one. Since trigonometric functions are many-to-one over their domains, we restrict their domains to make them one-to-one and find their inverse. The domains and ranges of inverse trigonometric functions are given on the screen. We have here inverse sine function, the inverse cosine function, the inverse tangent function, the inverse cotangent, the inverse secant, and the inverse cosecant function. How to find for the inverse trigonometric function? Let's have here the inverse sine function. Take note that y equals the inverse sine x or y equals arc sine x only means that sine y is equal to x. To find the value of the inverse sine function y, look for a value y in the corresponding closed interval for the inverse sine function, such that the value of sine y equals to x. The development of all the inverse trigonometric functions follows similarly from the inverse sine function. For our examples, let's start with the inverse sine function. Y equals inverse sine x. Take note the range is from -pi/2 to pi/2. My technique to properly solve and find the value for the inverse is to draw a unit circle. In the unit circle, I will locate the range or the possible values of my final answer. So in this case, for the inverse sine function, that's between -pi/2 and +pi/2 inclusive. Then I will know that my possible answers will only be in between those intervals. Now for our examples, find the exact value of the following. For number 1, inverse sine 1/2. To solve this one, simply have y equals the inverse sine of 1/2. Take note that that's equivalent to sine y equals 1/2. Now, our goal is to find an angle in which the sine is 1/2. So for number 1, that angle is pi/6 because the coordinates are square root of 3/2 and 1/2. And the sine is 1/2. Therefore, the answer for number 1, that's y equals pi/6. Final answer. For number 2 example, find arc sine 0. The same process, rewrite it one as y equals arc sine 0. Y equals arc sine 0 is equivalent to sine y equals 0. Our goal is to find an angle such that the sine is 0. That's basically the positive x-axis part wherein the coordinates is 1, 0, and that angle is 0 degrees or 0 radians. Therefore, y equals 0. Let's proceed to the second inverse function, which is y equals the inverse cosine x. The range is from 0 to pi inclusive. So our answer will only be from 0 and pi inclusive and nothing else. Example number 3. Find the exact value of the inverse cosine 0. Solution: we write it as y equals inverse cosine 0. That's equivalent to cosine y equals 0. Find an angle that the cosine is 0. So for this example, it's obviously in the angle pi over 2, where the coordinates are 0 and 1. That angle is pi over 2. That one with the red line, that's pi over 2. So our final answer for inverse cosine 0 is y equals pi over 2. Example number 4. Find the value of arc cosine negative square root of 3 over 2. Solution: we write it as y equals arc cosine negative square root of 3 over 2. The same thing, that's only equivalent to cosine y equals negative square root of 3 over 2. Our goal is to find an angle, probably in radians, such that the cosine is negative square root of 3 over 2. So in this case, it's actually right there, the 5 pi over 6 angle, because the coordinates of that is negative square root of 3 over 2 and 1/2. The x, or the cosine, is negative square root of 3 over 2, and that's what we're looking for. So for number 4, the value of y is y equals 5 pi over 6 for arc cosine negative square root of 3 over 2. The answer is 5 pi over 6. Now, for the inverse tangent function, the range is from negative pi over 2 and pi over 2. The same thing, my technique is that I'll draw a unit circle and then locate the possible values of our final answer, in this case, negative pi over 2 and pi over 2. Take note, the endpoints are not included. That's negative pi over 2 to pi over 2. For example number 5, find the exact value of the inverse tangent 1. For our solution, we write it as y equals inverse tangent 1. Inverse tangent 1 is just equivalent to writing it as tangent y equals 1. Take note, in the previous lessons, you already know that tangent y is just equal to sine y over cosine y. Do not be confused of y. Y is just an angle there. It could be theta or x. So in this case, we need to find a value such that tangent will be 1. So in this case, it's actually the pi over 4 angle, where the coordinates are square root of 2 over 2, square root of 2 over 2. Both x and y are the same, and that if you'll divide it, it's 1. Therefore, the value of y is that angle, pi over 4. Inverse tangent 1 is y equals pi over 4. Example number 6. Find the value of arc tangent negative square root of 3. Solution: y equals arc tangent negative square root of 3. That's equivalent to tangent y equals negative square root of 3. The same, take note that tangent y is equal to sine y over cosine y. Our goal is to find an angle such that the tangent is negative square root of 3. It's right there, because the coordinates is 1/2 negative square root of 3 over 2. That angle is negative pi over 3. tangent y now becomes sine y over cosine y. Sine, it's square root of negative square root of 3 over 2, and x is 1/2. Cancel denominators. Tangent y, negative square root of 3. Therefore, the value of y is negative pi over 3. Let's proceed to the fifth inverse trigonometric function, the inverse secant x. Note the range is from 0 to pi over 2. 0 is included. Union pi, 3 pi over 2. 3 pi over 2 is included. The same thing that I will do, but you cannot follow this one if you don't like. But my technique is I label the range and then I shade on which part will my expected answers be. Example number 7. Find the value of the inverse secant negative 2. Solution: y equals inverse secant negative 2. Equivalent to secant y equals negative 2. In your previous lessons, take note that secant y, or y could be any label. Y is just a label there. That's 1 over x, or 1 over cosine. So we need to find an x that is 1/2, negative 1/2, so that if we get the reciprocal, the answer is negative 2. So which angle is that? That angle is probably 4 pi over 3. Why? Because the coordinates of that angle is negative 1/2 and negative square root of 3. The x is negative 1/2. And if you substitute it, that's 1 over negative 1/2, and the reciprocal of negative 1/2 is negative 2. Therefore, the value of y is that particular angle. That's 1, 2, 3, 4, 5, 6, 7, 8. 8 pi over 6, that's 4 pi over 3. And that's the final answer. Y equals 4 pi over 3. And we have the last one, which is the inverse of the cosecant x. Take note, the range is from negative pi to negative pi over 2. Negative pi is included. Union 0 to pi over 2. Pi over 2 is included. The same thing that I will do, I'll draw on my side scratch paper a unit circle, labeling the range. The range is negative pi included, negative pi over 2 hollow not included, 0 hollow not included, and pi over 2 included. And then shade the possible answers for my inverse cosecant function. Let's have the last example. Find the exact value of the inverse cosecant negative 2 square root of 3 over 3. For the solution of this one, we write it as y equals the inverse cosecant of negative 2 square root of 3 over 3. That's equivalent to cosecant y equals negative 2 square root of 3 over 3. Take note that in the previous lessons, cosecant y is just equal to 1 over sine y, or 1 over y. Our goal is to find an angle such that cosecant is negative 2 square root of 3. So our goal is to find a y that is negative square root of 3 over 2. That's our goal. So it's located on that angle there. Why? Because our range is from negative pi to negative pi over 2. So that's basically negative 2 pi over 3. That's negative 2 pi over 3. Why is that the angle that we're looking for? Because the coordinates of that particular angle is negative 1/2, negative square root of 3 over 2. And the y, or the sine, is negative square root of 3 over 2. And if you substitute this one to y over y, that's y 1 over negative square root of 3 over 2. We get the reciprocal of the denominator. We rationalized it by multiplying square root of 3 over 3. The answer is negative 2 square root of 3 over 3, which is the answer that we're looking for. Therefore, inverse cosecant of negative 2 square root of 3 over 3 is the angle negative 2 pi all over 3. Y equals negative 2 pi over 3. Final answer. That ends all of my examples in solving for the inverse trigonometric functions. I hope you learned something today. Do not forget to like, share, and subscribe. I am Leigh Herbieto from Consolacion, Cebu.